Yep. I need a better job. Use the explanation.
All right, well, it's really quiet in here, and it's 8:03, so let's go ahead and review this as a group. So first of all, how do you find the y-intercept of any function? Any function at all? You just plug in 0. So hopefully we all have this memorized now that for any function that you ever have, if you want the y-intercept, you just plug 0 into the function, and that'll give you the y-intercept. And then how do you find the x-intercepts of a function? In general. What was it? Yeah, set the function equal to 0. So set f of x equal to 0, and then solve for x. And that's true if it's a polynomial, if it's a parabola, if it's a rational function. That's just all functions. You set the function equal to 0 and solve for x. And then how do you find the domain of a rational function? What part of the rational function do you look at? The denominator. So down here in the denominator, I would have my domain information. So you look in the denominator. And specifically, what are you finding in the denominator? So like, let's say that in the domain, I'm not allowed to let x equal 3 and 5. Yeah, they could either be a whole or an asymptote. So let's say that I had an x minus 3 in the denominator, which was also in the numerator. Then I know that since it cancels, that's an actual whole. Whereas if I had an x plus 2 in the denominator, but not in the numerator, then that would be a vertical asymptote. So my domain information is in the denominator, and specifically, if the term cancels, it's a whole. If it doesn't cancel, it's a vertical asymptote. And then, how do you find the horizontal asymptotes of a rational function?
So leading coefficient.
Yeah, the leading coefficient. So let's just say that if you FOIL it out. So first of all, that requires that you FOIL everything out. You can't leave it in factored form. This is something we've seen now a couple times. Sometimes you can only get information if it's factored, and then other times you can only get information if it's FOILed. So recall when we were talking about polynomials, when we were talking about a polynomial like f of x equals, if you have it FOILed out, like x to the 5th plus 7x to the 4th plus 3x cubed minus 2x squared, and so on. Well, in this form, you see the leading term, which will tell you the end behavior, and you can see the last term, which will tell you the y-intercept. You have no idea what the x-intercepts are. To get the x-intercepts, you have to actually take that and then factor it out into your various different factors. And now that you have all those factors, now you know the x-intercepts. So likewise, with a rational function, only if it's factored can you actually see the holes in the vertical asymptotes. But now if you want to look at the horizontal asymptote, you have to FOIL all of that out and actually take a look at whatever your, you have to FOIL it out and look at what your leading terms are. Only after FOILing can you do that. So again, you sometimes feel like you're going back and forth, back and forth. This format has certain information, this format has certain information. And likewise, even when you're dealing with one rational function, you need it factored to see the holes in the vertical asymptotes, but you need to FOIL it out to see the leading terms. So with the horizontal asymptote, let's just review the 3 possibilities. If the degree of the numerator is less than the degree of the denominator, so that's one possibility, then it simplifies down. If you have x times x over x, 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 you end up canceling 2 of them and you have 1 over x. And as you let x become a very large number, so you let x go to infinity, well then 1 over infinity is essentially 0. So that means your horizontal asymptote is at 0. So y equals 0 is the horizontal asymptote. And your graph will have an asymptote that goes down to 0. So that's if the degree is smaller in the numerator than in the denominator. If the degree is the same on top and bottom, let's say you have ax cubed over bx cubed, those are your leading terms. Well, then in that ratio, the x cubes both cancel and you're left with a over b. And whatever that is, that's the horizontal asymptote. Let's say a was 8 and b was 2. That whole thing comes out to be 4. So that means that y equals 4 is the horizontal asymptote. In which case, when you draw your graph, you go up to 1, 2, 3, 4. That's your horizontal asymptote, and then your function comes down and has an asymptote there. So that's only if the degree in the numerator and denominator are the same. You look at that ratio of the leading coefficients, and that becomes your horizontal asymptote. Last possibility is that your degree is larger on top than it is on bottom. And what do you have to do then? A little bit of work you have to do. What do you have to do? Long division, actual long division. And long division will tell you the what? The slant asymptote. Right. So you'd have to actually do the long division, and whatever the quotient is, so remember the quotient, so like let's say you had x squared plus 2 going into x to the 4th minus 7x cubed plus 2x squared minus 8x plus 10, and you're doing the actual long division, whatever you end up with right here, that's your slant asymptote. So let's say that that would be something like x squared minus 3x plus 4. Whatever that happens to end up being, that would be your slant asymptote. Typically, it's linear, so my example here is not the best. That's a slant asymptote could be anything. All right, well, I believe that's all the main ideas that we've talked about with a rational function. Well, we've probably said some other things as well, but those are the big ones. So where does that leave us? Today is October 8th. There we go. Today's technically our review day, so we are going to go over your practice test. And we're going to do that as a group. I'm going to have all of you sign up for one problem to demonstrate up on the board. And I'll be just walking around the room helping otherwise. I'll explain this process in a second. Right now, let's wrap up chapter 4. And I do owe you a joke. You're going to like this joke. This is, I know I always say this. You're going to like this joke. And I always say, you're going to go tell this to your friends. But you are. You're going to go tell this one to your friends. Okay, so you ready? It's a two-part joke. There are two fish in a tank. One turns to the other and says, "Do you know how to drive this thing?" All right, second part. There are two soldiers in a tank. One turns to the other and says, "Boom, boom, 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 boom." Thank you, Evan. Thank you, Evan. None of you saw Evan, but he's like, no. It's a great reaction. Okay, well, that's definitely one of my favorite jokes. So here we go, folks. We left off here. We finished this problem last time. There's a distance equals rate times time problem. And starting that problem off, we saw that d equals rt is one way to say the formula, but r equals d over t is another way to say the formula, and t equals d over r is another way to say the formula. And I just want to remind everybody, because this is a problem on your practice test, and it probably will be on your real test, that the core of this problem, other than making a note of all the information they give you, is that they're telling you it's the same time for both the car and the plane. And so the setup for this problem, say that the time for the plane is equal to the time for the car. That's the starting point for this problem. Right? You want to memorize that. The main part of this problem is saying that a plane can fly at 440 miles in the same time that it takes a car to go 120 miles. So I know that the time for the plane is equal to the time of the car. And from that, you can use your formula, t equals d over r. And then you say, well, the distance of the plane divided by the rate of the plane must be therefore equal to the distance of the car divided by the rate of the car. And then from there, you can plug in all of your information. You can say, well, the distance of the plane was 440. And the distance of the car was 120, and the car travels 80 miles per hour slower than the plane. So whatever the rate of my plane is, the rate of my car is 80 miles per hour slower. And that gets you to the point where you have your equation And then you can actually cross multiply and solve. So you cross multiply, you have 440 times r minus 80 equals 120 times r. And from there, you just finish doing your work algebraically solving for r. So I'm not going to finish the problem. I know we did this at the end of last class. I just wanted to kind of remind everybody how you start the problem and how fundamentally you set time equal to time and then use your time formula to set up the problem. Any questions about this one before we move on? All right. So the last couple of problems that we had are this shared work formula. This is an interesting setup. I think maybe you've seen, well, maybe you have, maybe you haven't. Maybe you've seen this type of problem in your Math 120 course, or maybe it wasn't in that course, but it's a particular type of problem. Let's take a look at number 10, where they say, Hannah can paint a room in 6 hours, and Destiny can paint the same room in 10 hours. So I just want you to consider, maybe Hannah and Destiny work at, say, a large office building or a hospital, and all the rooms are basically the same size. And over time, Hannah has found that she can paint a whole room in 6 hours, whereas Destiny can paint a whole room in 10 hours. Now, right off the bat, you might judge them. Like, if Hannah can do it in 6 hours, what's taking Destiny so long? Are any of you judging Destiny? Maybe you're not. In fact, maybe you're not thinking, gosh, Destiny, you slowpoke, you sure are taking your time. What are you doing, taking too many nacho breaks? I don't know. But maybe instead you're thinking, actually, no, Destiny is doing a good job. She gets the job done right. Hannah over here is speeding through it. She's doing a terrible job. She's missing parts. It doesn't look very good, right? So off the top of our head, is there any way of knowing which one of these two people are doing a better job? We don't know. This person could be going too fast. This person could be going too slow. Or maybe this person is taking their time and being careful, and this person is rushing it. We don't know. So maybe it's best not to judge either of them. But whenever I read a word problem, I like to play around and think, who are these people? Okay, so the point is that if Hannah can do it in 6 and Destiny can do it in 10, how long does it take for them to work together? Right, so how long does it take for both Hannah and Destiny to paint the room if they're working together? So any guesses? You know, just ballpark it. If it takes Hannah 6 hours and Destiny 10 hours, so Hannah is 6 hours and Destiny is 10 hours, how long do you think it should take reasonably if they were working together?
I would say it's an average.
You would take the average of them, maybe?
Yeah.
So an average would be 6 plus 10 over 2, which is 16 over 2, which is 8. So how does that sound? Does 8 sound like a reasonable amount of time?
Well, one is speed, one is slow.
Maybe. Now let's just keep in mind, what if they're working together, okay? And let's just say that Destiny falls over sideways because she's, I mean, who knows what? She's not dead. I'm not being morose, but it's just for whatever reason she has to leave. How long does it take Hannah to do it by herself? 6. So is 8 really a reasonable answer? No, but all by herself, Hannah can do it in 6. And if Destiny just straight up leaves, the answer should definitely still be 6 or less, right? So let's try to think of it that way. Hannah, let's just think about Hannah again. She can do it in 6 hours, and she's going to get help, right? So forget about the fact that Destiny takes 10 hours. Let's just say that Hannah gets help. How long should it take her?
Oh, 6 hours.
Yeah, less than 6 hours, right? So if you think of it this way, I'm going to erase this because it's not the average. But if we say to ourselves, okay, Hannah can do it in 6, but if she gets help, it should be less than 6, right? Even if she gets help from a toddler who can basically do nothing, she would still take her less time theoretically. And then what if Destiny, it takes her 10 hours, but if she gets help, it should take less than 10. So either way, you look at both of those numbers and you say it should take less than either of those numbers. And since 6 is the smaller number, our best guess is that it better take less than 6. Right? If they work together, it should take less than 6. And just conceptually, I hope we're all on board with that. That it should be less than either of those numbers. Now, one more thought experiment. What if they both took 6 hours? Let's just pretend for a moment that they both take 6 hours to do the job. How long would it take them to do it together? An hour? How do you figure it? Who said that? Who said that? Did you say that? No? Okay. An hour might be a little too quick. But what do you think? If they both take 6 hours to do the room and then they're working together, 3 would be the accurate answer. And just imagine, if Hannah takes half the room, how long, so this is half the room and that's half the room, how long will it take Hannah to do half of the room? 3 hours. And how long will it take Destiny to do that half of the room? 3. So either way, it's going to take 3 hours to paint the whole room because they can both do half the room in 3 hours. So just 3. So if they both took 6 hours and then they work together, the answer is 3. And we already know that ahead of time. We don't even have to do any fancy calculations with rational equations and polynomials or anything. If they both took 6 hours, the answer should be 3 hours to paint the room together. But if one is taking 6 and one is taking 10, this person is slowing down the process a little bit. So I wouldn't guess 3 hours. I would guess maybe something around 4. Maybe something along those lines. At that point, you really do have to do the computation. Anyone have any other guesses? If they work together, 6 and 10, about how long will it take? I'm going to throw out a wild guess that it's 3.75. So those are some possibilities. So now let's see how to actually solve the problem. How do you actually solve it? Well, fortunately, they give us a formula setup. And that formula setup is the shared work formula. So go ahead and jot it down. The shared work formula is x over a plus x over b equals 1, where x is what you're actually solving for. X is the time they take together. Whereas A is Hannah's time, and B is Destiny's time. All right, so that's our setup. And that's how the formula works. And I should be more specific. A is Hannah's time alone. That's if she works alone. And B is Destiny's time alone. That's if she works alone. And therefore, X is time together. You might want to clarify. X is time together. So let's go ahead and try this formula. I'm going to do it over here in the margin where I have a little more space. So my formula is x over a plus x over b equals 1. So in this case, x over Hannah's time is 6 plus x over Destiny's time is 10 equals 1. And we just need to solve for x. Mathematically, how do we do that? What is our first need? We need a common denominator. Right? We want to add. In order to add, you need a common denominator. One thing you can always do, I mean, if you want to find the common denominator at 6 and 10, if you want the least common denominator, what would that be? The smallest number that 6 and 10 both go to? 30. And you could sit there and think about what the least common denominator is and then make it 30. Or you can go ahead and just take this fraction and multiply top and bottom by 10, and take this fraction and multiply top and bottom by 6. It's going to give you a common denominator, but not the least common denominator. But it takes the least amount of thought process for you that instead of thinking cleverly, what's the least common denominator, which is 30, you can just go ahead and multiply each fraction by the opposite's denominator, and you get a common denominator. So then adding those together, we have 16x over 60 equals 1. Now you'll notice, had you used the least common denominator, then you would have been using, let's see, multiplying top and bottom by 5, multiplying top and bottom by 3, and then you'd have had 5x plus 3x over 30. And we would have ended up with 8x over 30. How does 8x over 30 compare to 16x over 60? It's just simplified. So you're still going to get the same answer. Like if right now I go ahead and simplify this, I'd have 8x over 30, and that takes me to the answer I would have had if I had taken the time to think about the least common denominator instead of just multiplying by alternate denominators. All right, so in any case, we have 8x over 30. How do we get x by itself? The quickest way? Yeah, you want to get rid of the 30 and the 8, and technically this is the fraction 8/30. The quickest way to divide up a fraction is to multiply by the reciprocal. So we could go ahead and multiply by 38. And that gives us x equals 38, which if you divide is 3.75. So that's it. That's how long it takes them to work together. And again, I want you to notice that we could at least have ballparked that answer from the beginning by saying, well, if they both work at a 6-hour pace, then they'd work together at 3 hours. Whereas if they both worked a 10-hour pace, then together they would take 5 hours. And so you're looking for a number between 3 and 5. Right? And sure enough, that is the answer we got, 3.75. All right, well, that's the end of the problem. That's how long it takes them to work together. Let's try one more. This one's a little different. A faucet can fill a sink in 5 minutes. So we've got a sink here. We've got a faucet. And apparently it can fill it in 5 minutes. Whereas the drain will empty the sink in 8 minutes. So the drain will empty it in 8 minutes. If the faucet is turned on and the drain is left open, how long will it take to fill the sink? Now let's just consider this situation. Will any water even stay in the sink? Because you've all had the experience yourself at home, like if you turn on the water in your sink, will it slowly start filling up or will the water just rush down the drain? I mean, theoretically, it just washes down the drain. Every once in a while, if you got yourself a situation and the drain is a little clogged or it's, it's clogged a little bit, then the water will start rising up. That typically happens where? Where does that happen to us from time to time? Sometimes in the shower, right? Every once in a while, if you don't clean your shower often enough, it'll hold water in the bottom and then you're standing in water. But that's why it's important that every once in a while you have to actually clean the drain in the shower so that it can drain at a proper pace. So in this particular case, if it takes 5 minutes to fill and 8 minutes to drain, will it hold water? Or will the water just flow straight through? Well, I mean...
Meaning that if you already started out, let's say you filled it up.
Okay, let's say you fill it all the way up.
Fill it all the way up. Now you still flowing the water.
Yep.
You unclog drain. Now it starts reducing, but you're still filling up at the same rate. It's just now the rate of the drain will start catching up at one point.
In this particular case, I'm not so sure about that because it's filling faster. It only takes 5 minutes to fill. So it's filling faster and it's draining slower. Because it takes 8 minutes to drain the whole thing. And that's a slower rate than the filling rate. Yeah, but I like your idea. If you fill the whole thing up, so it's full, and then at that moment you unplug the drain and you turn on the water, it would immediately start overflowing. Okay, so we know, so that's our situation. We have a sink, but we're starting with it empty. So start empty, and they're saying, how long will it take to fill? Now, of course, this is a little bit of a silly question because who's going to try to fill a sink with the drain unplugged? Right? Well, why are we even doing that? That seems a little strange. But nevertheless, they are asking the question, if the drain is open and you're trying to fill it, then how long will it take? How long would it take if the drain was stopped? How long would it take to fill the sink?
5 minutes.
Just 5 minutes. But the fact that it's draining, how long is it going to take? Well, just roughly speaking. More than 5 minutes. Right? So we know we should get an answer that's more than 5 minutes. Because if that drain was clogged, then it would just take 5 minutes. But since water's leaking out, it's going to take more than 5 minutes. And that's all we can really say, is that we're expecting an answer that's more than 5 minutes.
So it can be more than 8 minutes. So it's between 5 and 8, isn't it?
It's not like the previous problem. I don't know that we can really say that. I'm not sure. I don't think that we can say that. Yeah, I think at this point, we would have to do a little more thinking about how long it would take. Yep, I think we'd have to think more about it. But for now, let's use the formula. They gave us a formula, so let's take a look at it. It says x over a plus x over b equals 1. And so now one thing that we should be very careful with here is that in general, we need to do this formula in terms of, well, no, I guess we could do it in minutes. A lot of times it's helpful to stay in hours, but in this particular case,
Would it be an issue if both of them were same minutes?
right,
If one was minutes and the other one was hours, then I would say.
that would definitely be a problem. If one was minutes and one was hours, that'd be a problem. Part of me feels like I want to convert those minutes into hours just to be safe, because sometimes formulas require that you're working in hours. For instance, the D equals RT formula, distance equals rate times time. That more or less presumes that you're talking about hours and miles per hour, and you want to make sure all those units fit together. So let's go ahead and convert to hours just to be on the safe side. So 5 minutes is really how much of an hour? 5 minutes out of 60 minutes is how much of an hour?
1/12.
Yeah, 1/12, which if you do that on the calculator, let me get the calculator real quick. So the 5 minutes is really 0.083 repeating. That's that much of an hour. And then the 8 minutes, 8 divided by 60. So 8 minutes out of 60 minutes is really 0.13 repeating of an hour. That might feel a little inconvenient right now to have those repeating threes, but that's okay. This is good practice. Let's type it into our calculator that way. So we want to go ahead and solve this problem. There's one other consideration, and that is that one of these is technically a positive number, and then one of these is technically a negative number, because this 5 minutes represent you draining and putting water into the sink, and the 8 minutes is represent you draining and taking water out of the sink. So when we use this formula, let's say that A represents the 5 minute drain, or the 5 minute fill, and the B represents the 8 minute drain. Then what we're really saying is that the A value is positive, so that's positive 0.083 repeating. And yet the B number is negative 0.13, because you're draining it. So you have a positive value filling the sink, we have a negative value draining the sink, and that's what we're looking at. What's that? Yeah, it is time, but if you made them both positive, that would assume that they're both filling the sink. So one of them does have to be negative. All right, now at this point you might say, okay, well, Mr. G, this is all great, but how do we actually do this whole common denominator thing, because it looks like a terrible decimal? This is a fun exercise. Let's just go ahead and try what we did over here, which was you multiply by the alternate denominator, right? So if I multiply this fraction, top and bottom, by negative 0.13 repeating, and I multiply this fraction, top and bottom, by positive 0.083 repeating, then we are left with the negative 0.13 repeating x all over, and now I can multiply those. Let's see here, negative 0.13. When you do it on your calculator, I just put a whole bunch of threes. So negative 0.133333 times 0.08333333, and I end up with negative 0.01. So that's my denominator there. On this side, I have positive 0.083 repeating x, still over the same denominator, negative 0.01 repeating, and that should equal 1. Maybe this is the first time you've ever done a computation with a whole bunch of bars to represent a repeating decimal. Again, this is fun. This is a good experience. We can still do all these computations just so long as when you go to your calculator, when it says 1 bar, you just put in a whole bunch of 1s, like at least 10 of them. So now what do we have? Adding these two fractions together, now that we have a common denominator, I'm going to add negative 0.13 plus 0.083. And if I use enough threes, oh my gosh, it turned out to be exactly negative 0.05x over negative 0.01 repeating, which equals 1. Well, now what? Since we're in decimals anyway, we could just go ahead and divide these two on our calculator. Plus, it's a negative over a negative, so I know it's positive. So I'm going to go ahead and do 0.05 divided by 0.011111111. So I'm going to do 0.05 divided by 0.01111111111. Again, you just have to use a lot of ones. And I end up with 4.5x equals 1. And at this point, it's a simple algebra formula. We're just going to divide off the last 4.5. And what do we end up with? X equals 1 divided by 4.5, which is 0.2 repeating. Now, keep in mind that's 0.2 hours, because we started this whole thing off by talking in hours. So now our final answer is in hours. And what is 0.2222222 of an hour? How would I find out how many minutes that is? What's 0.22222 of an hour? You'd multiply by 60. So I take that and multiply by 60, and that gives me 13.3 repeating minutes. Or you could just say 13 1/3 minutes. Now at this point, you might be saying, Mr. G, did we really have to do all of that in terms of these terrible decimals? What if I had just done the whole problem using 5 and 8? So now that I just did all that with you, does anyone want to know, could we have just used 5 and 8?
Yeah.
Probably we want to know that, in the future, you really have to drill the decimals. Although, again, I like the decimal exercise because it reminds you that whenever you're dealing with decimals, you want to use as many decimals as possible so you don't lose accuracy in the problem. And it's fascinating to know that you really can do a whole problem using repeated decimals and you still get the correct answer at the end. But now if I do this and I multiply this fraction by 8 and this fraction by 5, then I would have 8x over 40 minus 5x over 40 equals 1. And that's 3x over 40 equals 1. And then if I multiply by the reciprocal, so that's 40 thirds, and that gives us x equals 40 thirds, which is, anyone want to take a guess? 13.3. And that's minutes. So apparently you can just go ahead and leave it in minutes, and that's fine. I wanted to play it safe by doing the whole thing in hours because sometimes the formula requires that you be in hours. But now through experimentation, we saw that both ways work. And that's a really valid process to go through on your own sometimes. Sometimes if you're not sure which of two methods to use, do them both and see if they end up agreeing with each other. If they agree with each other, then you know that you're okay to use either way. If they don't agree, then you do further analysis and find out why which one works and why the other one doesn't work. All right. We've got one last problem to do. Working together, Daniel and Donnie. Do you suppose people call them Dan and Don? I suppose so. They can clean the llama pen. You ever think math problems are just a little random? Like llama pen, right? It could have been a dog pen or a cat pen, but they chose llama pen. Do you know why they chose llama instead of cat or dog? For you. To add a little enjoyment to your day, that you did a math problem about a llama instead of a cat or a dog. So they can clean the pen. Ooh, this is tricky. Working together, they can do it in 45 minutes. What does the 45 represent? The X, the A, or the B? Now 45 represents the X. That's the time together. So in our formula, X over A plus X over B equals 1. They just told us X equals 45. Do I have to convert 45 minutes into hours? No. We just did that experiment up here. We can leave it in minutes. Okay, so 45 minutes. On his own, Daniel can clean the pen in an hour. So let's just say Dan is going to be represented by the letter A, which is an hour. Now, if that's 45 minutes, can I write 1 per hour, or I need to write 60? Because we do need to keep our units the same. So if we're going to be in minutes, make everything in minutes. If we're going to be in hours, make everything in hours. How long does it take Donnie to clean the llama pen? So Donnie is B, and that's what we're trying to solve. So they told us X, they told us A, we don't know B. So now we can plug all this into our formula. I'm going to get rid of some of this. So now we can say 45 over 60 plus 45 over B equals 1. So this is a pretty nice little versatile formula. So long as you know what the x, a, and b represent, you just take your knowns and you plug them into the form and then you solve for what you need to solve for. So we need to solve for b. How do we solve for b? What should we do first? We want to isolate the variable b. What could we do first? Yeah, we could go and subtract that over, right? Because we want to get b on one side of the equation by itself. So we might as well move that part over. And 45 over 60, even though we did everything in minutes, can't we go ahead and call 45 divided by 60 0.75? So now we have 0.75 plus 45 over b equals 1, because then we can easily subtract off the 0.75, and $1 minus 75 cents is a quarter. So now we have 45 over b equals 0.25. Now what? Now how do we solve for b? How do you solve for a variable that's in the denominator? Because keep in mind, although it's very tempting, if you have something like 45 over b equals 0.25, every once in a while I see someone tempted to divide both sides by 45. Like if I did 1/45 on both sides, then that would cancel the 45s, and I'd have 0.25 times that. But the mistake I see people make is now they put b right there. Why is that wrong? To divide off the 45 and then just write b. Where's the b technically? It's still in the denominator. So you can't just magically divide off the 45. You still have b in the denominator. So how do you get a variable out of a denominator? What do you do? What can you do anyway? Do what?
Multiply the reciprocal.
You could multiply by the reciprocal. That's an interesting idea. So like you're saying multiply both sides by b over 45?
You could, I don't know if that's right.
That's totally an interesting idea. It would work out. But what's another way to get the variable out of the denominator? What's it say? Cross multiply. Absolutely. This 0.25, you can put that over 1. And then you just have a typical cross multiply situation where you can do the 45 times the 1 and the 0.25 times the b. Getting a variable out of a denominator, cross multiplying, is a great technique. So now that gives us 0.25b equals 45. Now b is out of the denominator, and we divide off 0.25. And how many times does a quarter go into $45? I think 180. Right, because it's 4 quarters in $1 and $45, so that's 180. Okay, so b is 180. And what does that mean?
You have to convert it back to hours.
Well, if you want to.
Because if you started over there, then it gives him in 1 hour.
Well, we did everything in minutes, though.
Okay.
We did the 45 minutes, the 60 minutes. And therefore, b is 180. That means 180 minutes. And what does that mean? It takes Don 180 minutes to clean the llama pen. Which is how many hours?
3 hours.
3 hours. Yeah, so it takes Dan 1 hour, Don 3 hours, and together, working together, it should be less than 1, and in fact, the answer is 0.75. So all these numbers make sense. It takes Dan 1 hour, Don 3 hours, and working together, it only takes them 3/4 of an hour. All right, well, folks, that's it for chapter 4. I realize there's more in the packet, but you can all now go ahead and flip to the next page and cross that page out. We're not going to do the direct variation, inverse variation, and joint variation problems. And that brings us up to the present. So I do believe I took those problems out of your more homework. We might as well go ahead and take a look at that real quick to make sure that we're all on the same page. So here's more. And here's section 4.3. And there's the assignment for 4.3. And yeah, I removed a few problems from your homework. Yep. Yeah, okay, good. All of these problems are problems that you can do. Of course, if you have any questions at all, you can always feel free to post this question to the forum or message me, and then I'll get back to you. Does anyone want to ask any questions about the homework right now? No? Okay. Well, then let's go ahead and talk about the practice test. So your practice test. What we're gonna do, all of you theoretically have a practice test, right? Everyone has a copy, I hope. And it's due on Wednesday, because Wednesday is your test. So this is our day before the test. Your test is on Wednesday, and your practice test looks a lot like the real test. So you're all very motivated to do the entire practice test. I already posted the solutions online, and 2 of you already emailed me to let me know that I had 2 typos. So thank you for that. And I emailed you all back with the corrections to the typos. We can go ahead and look at those right now, because I think they were both on the first page. Right? I made the rookie mistake in the first problem of not noticing that the terms weren't in order. I just assumed. You know what happens when you assume? You make an ass out of yourself. When you make an ass out of you and me. I assumed that that was the highest term. It was not. So this is actually, the degree is 6. The maximum number of x-intercepts is 6. The y-intercept is still -2. The leading coefficient, therefore, is a 5. And to draw the picture of the end behavior, that's an even, and it's positive, so it looks like that. So there's that one. Gosh, I shouldn't have done that because that was a problem I was going to ask somebody to do. That's okay, I'll put my name there. What was the other problem somebody posted about? Which number? I think there was one other problem that I had a mistake. Let me see if I can find it. Oh, I do remember. Oh, and I'm so glad I can share it with you all. It's such a classic example of the human mind. It was chapter 4, number 3. Chapter 4, number 3. If you're looking at the answer key, so it's a long division problem where you do 2x minus 3 goes into 12x squared minus 16x minus 1. And I wanted to do that division, so what do I multiply by 2x to get 12x squared? I would do 6x. And so then that would be 12x squared minus 18x. Then I change the signs and add, so those cancel, and I get 2x. And then what did I do? I had a 1 there. I should have just dropped a 1, but I just wrote 2x, and my brain was thinking 2, and then I wrote down 2. So that's a classic example of what the brain does sometimes. The last thing you think or say is the thing that you write down. So that should have been a 2, that should have been a 1. So thanks for catching that, Carlos. Okay, so those were my 2 typos that I had on the test. So here's what I'd like us to do, folks. We have an hour and a half, which is like an eternity of time. We have an hour and a half, so what I'd like us to do is we're going to review this together. Let's read my instructions here. Let's look at it together. No, that's not the instructions I want to give you. So here's what we're going to do. This will be a little interactive where I'm going to ask all of you to come up and sign up for one problem that you'd like to model on the board. So these are all the questions from chapter 3 right here, the first part of the practice test. And these are the questions from chapter 4, the second part of the practice test. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, about 28 problems. And there's 4, 8, 10, 14, 15, 16, 17, 18, 19, 20, 23. Well, there's only 23 of you. So that's fine because I was going to sign up for that one because I made a mistake on it. And then I signed up for this one because I made a mistake on it. So in other words, all of you can come up and choose one problem that you're going to do on the board. All right? So in a minute here, everybody can come up, put your name next to one problem. And then what we'll do is I have the problems up here. The basic flow for the rest of the class will be this. Like for instance, here's problems 1, 2, and 3. So the first thing I do is ask for these people who signed up for 1B, 2, and 3 to come up to the board. All 3 of you will come up and you'll write your full solution on the board, but no one's going to be watching you. Like you don't have to feel self-conscious. While you're up here writing up your instructions, the rest of us are just going to be working on our own. I'm going to be walking around the room, answering questions. You'll be working with each other, asking, hey, what did you get on this problem? Hey, how did you do that? So the people on the board, you don't need to feel self-conscious. No one's going to be watching you. And then you can just sit down, right? You come up, you write up your solution, then you sit down. And then once those 3 people are done, I will come up to the board, review those 3 solutions, take any questions, and then I'll say, okay, the next 3 people come up. And then the next 3 people come up, and while they're writing the solutions, I'll be walking around the room helping. So my only request is, as I'm walking around the room helping, and I get to you, I hope you have a question for me. So like if I get to you, Austin, I'm like, Austin, what's your question?
I hope that you don't say, I don't have one. Right? I hope you have a question. So everybody right now, flip through your packet and first find a problem that you wouldn't mind demonstrating, but then also find the problems that you want to ask questions about so that when I get to you, I can help you with something. So that's it. We have essentially an hour and a half to do a work session here where you can help each other and I can help you, and you're all going to help each other by putting solutions up on the board. And so by 10:20, we should be totally done going over every problem in the practice test, and you'll feel very, very confident about everything. Okay, so here's a whole bunch of markers. You can all come up here. Don't push, don't shove, don't hurt each other. So come on up and put your name next to one problem.
Which one do you want?
And then return to your seat and just start reviewing your test, and I'll walk around and help.
Yeah, I'm gonna do that one because I did these already. So.
I'm going to start with you. Which question do you have?
You just put it all up on me. I'll do this.
Didn't do anything from chapter 1. Chapter 1 is easy.
The question was,
Which one? This one? This one's easy. All you have to do is set the denominators equal to 0. No, it's easy. It says the vertical axis and vertical axis with the denominators.
Right. So
Yeah, I'm positive.
if in the graph is a single slice, then the exponent if the graph is balanced,
Remember?
then the exponent It's right here. You have to put it on the board for everybody to see. Yeah, that's a really good point. Go straight through the one, goes to the
Oh, I'm sorry, I picked the one.
Okay, great. And then did you take your formula and plug it into Desmos and see if it actually looks like that? Really good last thing to do. Okay, find another problem. I'll come back. Yeah, great. What question would you like to ask? Okay. What's the maximum number of x intercepts? The degree is the maximum number of x intercepts by definition. So if you have a polynomial like f of x, whatever the first term is, like 8x to the 10, whatever the highest degree is, that's telling you the most number of x intercepts across the graph. It's also telling you the most number of weights. It's saying that since it's x to the 10th, you know the end behavior is even, so the end behavior is like this. And then it's saying the most number of times you cross the x. So that would be 1, 2, 3, 4, 5, 6, 7, 9, 10. And that's what they're saying about the highest degree. It's a really good question. 7A, yeah, would be the first one. Sure. Okay, so what's that? I'm going to tell you in general that if you have a graph that slices straight through, then that particular x-intercept, you would have a power of 1. If you have a graph that bounces like that, so a bounce, then that particular x-intercept is a power of 2. Whereas if you have an x-intercept right there that comes in and goes horizontal before slicing through, which is different from this. This one you cut right through. This one you actually go horizontal before going back down again. Then that x-intercept will be. Yeah. Does that answer your question? Okay, great. Awesome.
Wondering how much we're trying to use to.
These two? Well, let's look at this one first. So first of all, you have your x plus 4, very good, your x minus 3, very good, and they both bounce with 2, and that's correct. So next, it says write an equation for polynomial. You know you can always start with f of x equals, and then there's going to be some sort of coefficient, and then that equation. So far, this is the beginning of the problem. Write the polynomial in factored form simply using c as a linear coefficient, so you're done. Now, because the problem says you can just use c as a linear coefficient and not further solve the problem. But if you did want to solve the problem, you could say, well, I know the y-intercept is the coordinate 0, -1. That means if I plug in 0, it should equal -1. So if I plug in 0 for x, this whole thing should equal -1. So you could say f of 0 equals c times 0 plus 4 is 4 squared, times 0 minus 3 is -3 squared. And all of that should equal -1. So now you just focus on this part right here, and it's a simple equation in one variable. You can solve for c. So now we have c times 16 times 8. 8 times 16 is what, 108? I did that a little too quickly. I might have done that wrong. But so I have now c times -108 equals -1. Let's check that. 4 squared is 16. Oh, no, I'm totally wrong. 3 squared. I did that backwards. 3 squared is 9. 9 times 16. Oh my gosh, 9 times 16. That's -144. Nope, it's a negative squared, so it's positive. Well, see, I'm working way too fast, Austin, and I'm doing it upside down. Silly me. So now I have c times 144 equals -1. I divide off the 144, and now c is -1. So now I can go back and fix this first equation. It's really f of x equals -1 over 144 times x plus 4 squared times x minus 3 squared. And if you type that into Desmos or your TI-80 calculator, it should look exactly like that.
So if we were solving for c,
That's how you do it. Yeah. And that's how you're going to start this problem. So this polynomial, degree 4, has multiplicity of 2 at 4, yep, and then roots, multiplicity of 1 at 0 and -1. So far that's correct. It goes through the point 5, 4.5. So that means that you're going to have f of x equals c times 11. And since it goes through that coordinate, that means if you plug in 5, it should equal 4.5. So if you plug in 5 in for x, and you plug in a 5 in for y, it should equal 4.5. Does it make sense? So if I plug in 5, 5 minus 4 is 1, 5 plus 8 is 5, 5 plus 4 is 9. So now it's just a matter of multiplying all that out times c, and then dividing the number out times c. Finish that problem.
And I thought you had to wait, no, so I took out the eyes off. And then, from there, like.
Okay, so folks, so far so good. I just went through the first row, answered all of their questions. I'd like to go ahead and have the first 3 people come up. So that's Evan, Jose, and Carlos. You can come up and do 1B, 2, 3. Again, nobody watch them. Don't even look at them. Let them work on their own. And I'm just going to keep walking around the room and helping you. So hopefully when I get to you, you have a question. All right, Annabelle. Not yet. Okay, I'll come back. I'll come back. I see.
I would.
Okay. So it says find all the zeros of this thing. So you have the 4, -24, 24, and 20, and you have all the numbers. Okay. End of the zero separated by commas. So, see, the question is, what do we start with? What number should we start with? Right? They didn't give us a number to start with. So there's a couple different ways we can do it. I think the easiest way would be to plug that thing into your graphing calculator. And thank you, guys. This will tell this to everybody. So 4x cubed minus 24x squared plus 24x minus 20. And provided you're in a good window, let's do that window. The graph is going to show you the first x-intercept. Right? So the first x-intercept is apparently at 1, 2, 3, 4, is that a 5? Well, let's find out. So we'd have to do trace. Actually, what we can do is second count and do the value. And let's just plug in 5 and see if that really is. Yep, 5 really is on the x-axis. So I know that 5 works. So I'm going to use that. That's just to get you started. That way you don't need to sit there and guess a whole bunch of numbers. You just know that 5 is going to work. Now, had you just, I would just plug it in to get the first one. Now, also remember Descartes' rational roots theorem says that this is your p. Wait, was that p and this was q?
I know.
Then you do all the factors of q over all the factors of q. I think this was q. Makes no sense that Descartes would do it that way. But we're going to look at all the factors of 20 over all the factors of 4. I know it's that way. It's this one over this one. And so all the factors of 20 are 1, 10, 5, 4, 2, and 1. Over all the factors of 4, which are 4, 2, and 1. So you'd have to sit there and make every possible fraction of all those numerators over all those denominators. And in that gigantic list of numbers, 5 was on that list, which is one of the numbers that we could have tried. But again, we used the calculator to get us there quickly, rather than going through the list and trying everything one at a time, which is a lot of trial. Okay, so now do the synthetic division of 5.
Yeah.
I'll stay and wait. Wonderful. So now at this point, you don't even need it to do anything more, because this part now is, since you started an x cubed, now it's quadratic, so put in the x squared in the x. There's no further need to do more synthetic division. Like, you don't need to try to find another number to guess, because now that this is just a quadratic, you can use the quadratic formula. So far, what you have here, since you've got these two parts, you know that x minus 5 times 4x squared minus 4x plus 4. Now, the first thing we need to do is pull out a 4, because you can pull out a 4, so we need to. So we'll pull the 4 out front, and now that gives us x squared minus 1x plus 1. Now, this you can just use the quadratic formula, and that's going to tell you the other x-intercept. In fact, that's all they want. Enter the zeros separated by commas, find all the zeros. They just want all the x-intercepts. So you know that one x-intercept is 5, and then the other x-intercepts are the quadratic. Yeah, good one. Finish that up and let me know if it works.
We just picked one of the we just put the smallest number and
Hey, what question would you like? Okay, so I would say always want to start off with writing just a general equation, which we know that, let's see, we know that one x-intercept is at -4, so that means the factor is positive. And we know one x-intercept is positive 3, so the factor is -3. And we know that that's a bounce, so I'll do the power of 2, and that's a bounce, so I'll go to the power of 2. And so far, that's all I know for sure, is that I have this, and I have this x minus 2. Now, the other thing that I have is the coefficient. You never know what the leading coefficient is, so we can use the letter C to say, well, there's some sort of leading coefficient. +1, or it could actually be nothing. Okay, so once you write down this is the start of the problem. The last thing you want to look at is the y-intercept. The y-intercept is more than 0, -1. That means you plug in 0, to become this whole formula, and you plug in 0. So I'm just going to plug in 0 for those things. 0 plus 4 is 4. 0 minus 3 is -3. All of that then should equal. So now it's just a matter of solving this equation for C. So I had C times 4 squared is 16. -3 squared is 9. 6 times 9 is 144. So I have C times 144 is -144. And I can divide off the 144. And that gives me my C value. So C equals -1. Now you can finish writing down the whole thing. F of x equals -144. That, if you type that in your calculator, you'll see exactly that. Okay. Sure. Okay. Okay, folks, let's review these first set of problems. First of all, doesn't this look lovely? It looks lovely. So I'm sure I'll compliment all of you. But the first 3 people who came up, this looks really good. It's visible from the back of the room. Let's go ahead and look at these solutions. The first person was Evan. So Evan was looking at a polynomial with degree 6, which means the maximum number of x-intercepts is 6, because the degree is the maximum number of x-intercepts, right? That's the definition of the maximum number of x-intercepts is the degree, the highest power of x. He also had the y-intercept was -20, the leading coefficient was -1, and since the end behavior is even and it's upside down, so it looks like this. So all of that is fantastic. Thank you, Evan. Number 2 was Jose. So it says, given this function, find the y-intercept. So Jose, how did you find the y-intercept? Yeah. Absolutely. You just multiply all the numbers inside the factors, and that gives you the y-intercept. So 72. And notice he didn't change any signs. The y-intercept is literally the product of the numbers inside the binomials. Not the leading number with the x, but the second number. So -6, 3, and -4. That's the y-intercept. And then what are the x-intercepts? Exactly, you just set each of those equal to 0. Probably these two you didn't have to set equal to 0. What did you do? You just took the opposite sign. So the opposite of -6 is 6, the opposite of 3 is -3. This one you do actually set equal to 0. So 7x minus 4 equals 0. If you solve that, you get 4 sevenths. So that's it. Those are the x-intercepts. That's the y-intercept. Nicely done. Thank you, Jose. Number 3 was Carlos. So in number 3, it says you're given this function, and now you want the y-intercept and the x-intercepts. You'll notice these two questions are asking the same thing. What's the y-intercept? What's the x-intercept? What's the difference between the equations? You know, one is factored and one is foiled. Right? Again, this idea that you can have an equation either factored or foiled, and you get different pieces of information. So in this particular case, the y-intercept is 0 because there's no number at the end. The y-intercept is always the number at the end. There is no number at the end, so it must be 0. Whereas the x-intercepts, Carlos had to do a little bit of work. He took his equation, he factored out 4r squared. That left him with r squared plus 1r minus 6. And that you were actually able to factor, right, Carlos? So what do you multiply to get 6 that you had to get 1? 3, and did you mean 2?
Yeah.
Yeah, there we go. Little typo. Thanks for doing that, Carlos. That makes me feel better about all the typos I make. You did that on purpose, didn't you? Just to help me feel better. I appreciate that. So he factored in r plus 3 or minus 2. That's correct. And therefore, now using the zero product rule, he set each of those equal to 0. So 4r squared equals 0 means r equals 0. And then r plus 3 equals 0 means r equals -3. And r minus 2 equals 0 means r equals 2. So technically, you have one more. Oh, yeah, here it is. 4r squared equals 0, so r equals 0. So 0, 2, and -3 are the x-intercepts. So your final answer, what are the x-intercepts? 0, 2, and -3. And then you could go about making a picture of the graph. But that's all you had to do in that particular case. Thank you, Carlos. Folks, any questions about those first few? Okay, so it's 9 o'clock. My phone just went off. Let's take a break. So we'll all be back in the room at 9:14. And those next 3 people, if you already want to come up and do your part, you can. Let's get numbers 4, 5, 6. So Austin, Ashley, and is that Jonathan?
Yeah.
Okay. Yeah. Austin, Ashley, Jonathan, feel free to take a break. I'm sorry, it was so nice and cursive-y, and I just wasn't sure. So you 3 can come on up, or you can just take a break and come up when you get back. Otherwise, folks, let's take a break, and we'll come back and keep going through these problems. Nice work.
Myself.
Oh, sorry.
Oh, good.
And it's not really for that. It's more about my calculation.
Okay, that's fine.
The one you explain to others, it's just finding that
A good window.
window, and that will help.
Yeah.
Because when I do it on this one.
It's easy, right? Yeah, I'll show you.
On my computer, on my calculator, I'm like,
Yeah, I'll show you.
oh yeah.
Hey, it's Kevin. Kevin, I was just sitting here looking at my fastback folder thinking, gosh, I wish Kevin was here so that I could give him his stuff back. So there's Good test. Here's just a packet from the very first day of class that you went there to receive. And then here, I think I have a couple other packets to give you. Okay, let me see here. I don't know if you've got some of these. So you tell me, did you get the chapter 4 packet? I don't think you did. I don't think you did either. Here's the intro to chapter 4. Yeah, I have. No, I don't have one of those right now because I just gave out the last one I had. But you can come see me right after class and I'll give that to you. Now, did you get the chapter 3 packet? No, okay, let me put these in order. So chapter 3, this was the end of chapter 3. And then this was the beginning of chapter 4. And there's chapter 4. And then this was, this was actually an introduction to chapter 3. There we go. And then that was your previous test. So now these are in order in terms of the work that we did. And I should tell you which ones I'm going to collect, like this one. And collect this one. The other ones are notes that we did in class. Okay, you just got here, right? Okay, are you staying?
I got here now. And yes, sir.
Oh, were you in here? Oh, you're okay. But I mean, you just got here.
Yeah.
Into my class. Okay, so you can stay, see the rest of the class. Gosh, I want to give you a practice test, but
I'll come to the
right. But I mean, that way you can be working on this while you're in here because you're going to stay, right?
Yeah.
Okay. So let me email it to you. Can you walk over to the Learning Center and print it? Okay, I'm going to print it, or I'm going to email it to you right now. Hi there, Val. Well, you've got all the factors of 16 over all the factors of 9. That's correct. You have all of the fractions. That's right. And then the number of possible positive x-intercepts is the number of times the sign changes. So once, twice, just twice. So, and then you start subtracting 2. So 2 minus 2 would be 0, minus 2 would be negative 2, but we're not concerned about negative values. So you either have 2 or no positive x-intercepts. And then for the number of possible negative x-intercepts, you change the sign on the odd-powered terms, so like x to the power 3 and x to the power 1. So now, if I change the signs, that's going to, instead of a positive sign, it'll be a negative. Negative 45 is the next sign. Positive 32 is the next sign. Oh no, I have to change that one, sorry. I should be minus. And that last one is positive. So now how many times does the sign change? No, yes, only once. So now it's either 1 or you subtract. You start subtracting 2. That would take you down to negative 1, but that can't be it. So what this tells you is that the number of positive x-intercepts is either 2 of them or none of them. And the number of negative x-intercepts is definitely just 1. So if you were to look at a graph, and you were to say, what does this graph look like? You would definitely have 1 negative x-intercept. And then you either have 2 positive x-intercepts, in which case the graph would look like this. Or you have no positive x-intercepts, in which case the graph would look like this. And that's what you're talking about. And then the synthetic division work, you have to find what number to plug in to actually get your answer. I would go into your graphic calculator and actually just look and see where the x-intercept is. You know that there's a negative x-intercept. So go onto your calculator, find the negative x-intercept, and use that number as your synthetic division. Here's your Hey. Oh, you're just walking by. Oh yeah, you can pull it down and then push it back up again. Or you can just do it anywhere you like. Yeah, pull it down and then push it back up. That'd be fun.
Is this the correct way to do the slant asymptote?
Where?
Number 2. So it's
Yeah, you're gonna do the
X
long
over 1.
division of x cubed plus 1 divided by x squared plus 2. Where did? Oh, and you did it right here. You need to put in the zeros. So you'd have x cubed plus 0 x squared plus 0 x plus 1.
Mm-hmm.
At least I think you do. Maybe you don't need to actually need to do
Well,
that.
I mean, there's just no x, so in my mind.
Well, that's true. That's true. I guess you don't really need to. Yeah, it's just not there. Yeah, that's fine. So then what, the slant asymptote is just x?
So is this the slant asymptote right here
Yep.
at the top? Okay, so I crossed it out for some reason. I was like, what the heck?
Oh yeah, no, that's it. That's your slant
So
asymptote.
then it would be like y equals x
Mhm.
plus 0.
Yep.
Cool. So then you can show me how to factor trinomials with a coefficient.
Yeah, where?
It's trying to get the x-intercepts for this one. So.
Yeah. So with a coefficient, you multiply the first number times the last number, so that's negative 15, and then you say what multiplies to make negative 15, either 1 and 15 or 3 and 5. Then you say which of those adds to make negative 2. So it'd definitely be the 3 and the 5. The 5 would be negative, the 3 would be positive. So now what we do is we rewrite the middle term. So 3x squared, and now my middle term is going to be, I'm going to do the minus 5x first. Minus 5x plus 3x minus 5. So all I did was really rewrite the negative term, because negative 5x plus 3x is still negative 2x. Now I group the first two, I group the second two. From here, all I can do is pull out an x. And then from this one, I actually can't pull out anything. So I just put a 1 out front. And now 3x minus 5 is part of both of them, so I can pull the 3x minus 5 out front, leaving behind the x and the plus 1. And now it's factored. That's the process.
All right. Cool. Thanks.
You're welcome. Yeah. Put parentheses around the x squared minus 4x plus 29 part. Use synthetic division to find the quotient and the remainder. Oh, yeah. So they specifically want you to write down the quotient is and what the remainder is. So you probably want to say, so this is the divisor. This part. Wait a minute. You started out as x cubed. Where's the rest of it? You're missing an x term. So that's x cubed, x squared, no x. So you want to move that to a 0 here, and then 21. So unfortunately, you need to go back. Okay. Yeah, there you go. All right, folks. All right. I will continue walking around the room and helping. So when I get to you, I hope you have a question. Let's see. Stop it. What was your question? Oh, I did. Okay. Great. No problem. So in this particular case, there are two ways. You could just cross multiply. And it's probably the quickest and easiest way. Because then you would just have 1 times x plus 2 on one side, and then you have 4 times x minus 2 on the other side, and at that point you just distribute and then move all your x's to the left. But if you were to think about the way we have been talking about, like how you're going to solve this problem, you first have to factor the bottom part here. So and that makes sense because that's negative. So to do this problem, the way we've been talking about in class, you would need to multiply all the way through the x minus 1. Multiply that by each of those numerators, because that way it's going to cancel all of them. So that's how you do this problem. So in this case, you can do the same thing. You can say, well, the denominator, if I want to cancel the x minus 2 and x plus 2, I have to multiply all the way through by x minus 2 and x plus 2. Because when you do that, when you multiply this term and this one, the x minus 2's cancel out, and you're left with 1 times x plus 2, which is what this is. And if you multiply this over here, then the x plus 2 cancels out. And you're left with 4 times x minus 2, which is also 2. So cross multiplication is really just the simplified result. result of what happens when you multiply through like number. Either way, you can do it either way you end.
You give me the.
Other question?
I'm saying too, because we're not just
Find out. Can you get this answer? Solve it, or can you?
Well, so you listed out all the possibilities, and then you went ahead and you knew that it was 4. Did you graph it?
Oh, yeah, put it on my computer, that's how it's done.
Yeah, that's how you got 4. Now we're recognizing. So now, since you already know that there's 1 positive x intercept, you can only have 2 or none. So let's see if there's nothing positive x intercepts. And indeed, don't you define another one?
Yeah.
Yeah, so there are in fact 2 positive x intercepts and only 1 negative x intercept. But you do this first. You just go ahead and you take the sign selection. So the number of positive is positive x intercepts. That's a positive. That's a positive. So how many times does it change? One change, 2 change, so that means it's either 2, and then you start subtracting by 2's. 2 minus 2 is 0, minus 2 is negative 2. You can't have negative x intercepts. So it's either 2 or 0. Then what you do is you just change the sign on the odd power terms. So now this would actually be a negative. That's still in 2.5. This would become a negative. And then that's still a positive. So how many times does it change? No, just once. And again, you'd say 1, and you start subtracting by 2. 1 minus 2 is 1. You can't have a negative intercept since that. And that just gives you the theoretical result that you know to expect 2 or no positive x intercepts. And since you count 1 positive x intercept, you know there's going to be a negative. And you also knew for sure that you would definitely have a negative x intercept. So, you know, that might suggest to start looking for the negative x intercepts first. But I would suggest putting it in the Oh, Valerie, I'm taking your seat. I'm so sorry. Okay, folks, let's all turn our attention up on the board and go through these next couple of problems. Hold on a second. I want to see. Did Austin, did you do yours? Oh, it's right there. And then Ashley, where's yours? Right there. And then John, where did yours go?
Below all those.
Ah, there it is. All right. So let's start then with number 4.
I like that.
Number 4 is in the red. Okay, here we go, folks. So number 4 was completed by Austin. Thank you, Austin. So number 4, you just had to use synthetic division to find the quotient and the remainder. So he went ahead and he did the x squared minus 2x squared plus 0x plus 21. Did you two do the same problem?
Yeah.
Okay, well, that's fine. That's fine. So he did his long division, and he ended up with x squared minus 4x plus 8 as the quotient, and then the remainder was 5. And that's it. So wait, this was who? That was you, Austin? Okay, yeah. So yeah, just by doing long division, it said that. Now it did say though to do synthetic division. So that's nice that Ashley did this as well. So Austin, that's fine that you did long division. I would still give you full credit for that.
Okay.
Yeah, because he still found the quotient and the remainder. But now let's see the synthetic division way. So Ashley had the 1, negative 2, 0, 21. She did synthetic division using number negative 2. She did her whole process. This is the quotient, and that's the remainder. So she just labeled it, and that's fine. You'll notice that she and Austin got the same answer, x squared minus 4x plus 8, and the remainder of 5. That's really helpful that you both did it in 2 different ways because you can see where the answers are. The divisor is the negative 2, or x plus 2. That's the divisor. In fact, here, Ashley, I'm going to label it right here. This is your divisor. This was your quotient. And then this was your remainder. So that was handy. Thanks, Austin. Thanks, Ashley. I bet you two got together and did that on purpose. That was fantastic. Nice collaboration. Okay, then number 5, which is where? Oh, nobody did number 5. So I'll do number 5. Yeah, right. So that's fine. I'll do number 5. So, folks, number 5, it says the polynomial of degree 4. So I already know there should be 4 factors. Has a root of multiplicity 2 and x equals 4. So I know that's x minus 4 to the power of 2. Right? The x-intercept is 4. So it's x minus 4. And it has a multiplicity of 2. So that's to the power of 2. And then it also has a root of multiplicity 1 at x equals 0. So that means multiplicity 1 at x equals 0. And a multiplicity of 1 at x equals negative 4. So that's really x plus 4. So far that's what I know, except I also need a coefficient. You always need a coefficient because you don't know what value is right there. It could just be a positive 1 or a negative 1, and that'd be very convenient. But it could also be some other value entirely. So at this point, once you set up your x-intercepts and your coefficient, they told us it goes to the point 5, 4.5.
When you look at the 0.5, 4.5, that's your input and that's your output. That means if I plug in 5 for x, so I'm going to go all the way through, plug in 5 for x, then that means that it should equal what? 4.5. So that's your process, folks. They have you set up the polynomial first with the leading coefficient, and then you solve for the leading coefficient by them telling you one coordinate, which is an input-output. So if I plug in my input of 5, then now this whole thing should equal 4.5. And I'm boxing that up because that's actually what I'm solving. At this point, I kind of ignore the P of 5. I'm just focused on solving the rest of this equation and solving for C. So how do we solve for C? I've got C times 5 minus 4 is 1, 1 squared is 1. 5 minus 0 is just 5. Then 5 plus 4 is 9 equals 4.5. So now I have this. 1 times 5 times 9 is 45, so that turns out to be 45C equals 4.5. And if I divide off 45, that gives me C equals 0.1. Or in other words, 1/10. So at this point, we have our final answer. I can go back to my original polynomial here. My answer is going to be P of x equals 1/10 x minus 4 squared times x minus 0, which is just x to the first, times x plus 4. So that's what your final answer would look like. Did I do that right? Was it 1/10? Okay, yeah, it's 1/10.
Can I have left it as a 0.1?
You can leave it as 0.1. You can do it as 1/10. Both of those are just fine. I would say the main thing to keep in mind, folks, is that when you're setting up a problem like this, you would start by writing down the structure of the x-intercepts and then writing a C for the coefficient you have to solve for. And then use the information from the coordinate they gave you to say that if you plug in 5, it should equal 4.5. And then you have to go through simplifying that arithmetically. It's just arithmetic. And then solve for C. And then you write down your final answer. All right, so number 5. Thank you, Ashley, for doing number 5. Now, number 6. That is done by Jonathan. So Jonathan did the same thing, but instead of being told that information verbally, he was given a graph. So in his graph, you'll notice he had an x-intercept at -4, which means a factor of x plus 4. And he had an x-intercept of -3, which is a factor of -3. And since this is a bounce, he knew to have an exponent of 2. And this is also a bounce, so he knew to have an exponent of 2. And therefore, he wrote down his original formula, f of x, as a coefficient times x plus 4 squared times x minus 3 squared. That's what he had so far. Right? Jonathan? What's this little -1 right here? You were just writing down what the y-intercept was? Yeah, I'm just move that there for a second. Okay, so then what he knew was that because he had a y-intercept, the y-intercept is equivalent to knowing this point, the input 5, output 4.5. The y-intercept is what you'll use, because the y-intercept is easy. You plug in 0, and it should equal -1. That's what the y-intercept tells you. So you're going to use the y-intercept to solve for C. And that is, in fact, what Jonathan did. How did you do that, Jonathan? You wrote this out as x plus 4 times x plus 4 times x minus 3 times x minus 3. You plugged in 0, right? I'm just going to wrap some parentheses around this, Jonathan, so everyone can follow along. This was your formula, right? And you knew that all of that should equal -1. So he plugged in 0 everywhere he saw an x, and that way it was just C times 0 plus 4 is 0. I'm sorry, 0 plus 4 is 4, 0 plus 4 is 4, 0 minus 3 is -3, 0 minus 3 is -3. So that would be 16, 4 times 4 is 16, but -3 times -3 is what? Positive 9, so that would be your 9. And that gives him C times 16 times 9 equals -1, which is positive 144C equals -1. So he divided off the 144, and you end up with what? -1/44? -1/144? That's correct. So that you just need a negative sign. Yeah, very nice, Jonathan. Overall, that's the flow. That's the flow. So again, folks, in both of these types of problems, it's important that you start by setting up your problem as f of x equals C times x plus 4 squared times x minus 3 squared. And then you know your y-intercept is 0, -1. That means if you plug in 0, and you just go straight across, plugging in 0, it should all equal -1. Now, I like how Jonathan did it by breaking it all the way up, because then he was able to clearly see 4 times 4 is 16 and 3 times 3 is 9.
by plugging in the zeros into the original formula, you still get the same thing. We have c times 4 squared times -3 squared equals -1. And then you can still multiply all that out on your calculator in your head. That's -144. C equals -1. Oh, nope, sorry, positive. And then dividing off the 144, you get C. Okay. Now, folks, I should point out that in this particular problem, Jonathan and I went more than I needed to. I said write the polynomial in factored form simply using C as the leading coefficient. So you could have just written down this, just having a C right there. That's technically all I really asked for. But that was a really good exercise to solve for C, because that's the skill that we're building in this problem. And this problem is how do you solve for C? But in this particular problem, had you just written f of x equals c times x plus 4 squared times x minus 3 squared, that's all the instructions really asked for. But going further and solving for c is good. Okay, well, let's keep going. Thank you very much. That was Jonathan, Austin, and Ashley. So now let's have Valerie, Andrew, and Valerie, did you sign up twice?
No.
No, that's me.
Oh, Val, there we go. Val and Valerie. That makes sense. So let's have all the way up through 8. So that would be Valerie, Andrew, and Val. Come on up. Come on up, if you would, please erase the board and write up your solution. And I'll keep walking around. Good. Nice solution.
So, okay. So find all the zeros. We don't know anything ahead of time, so the right to accept the rational roots there. And you look at every possible fraction. So that's what you want to test, is to write out every possible fraction. So all of these over 1, and then all of these over 3, and then all of those over 3. So it's writing out like that. Okay. Done.
So then.
Yep. Oh yeah. So that's already your list. Like the first one. Yes. Everything over 1. Then you have 1/3, 2/3, 1/3, 8/3, 16/3, and then you have 9, and all of that with a plus or minus in front, and that's all the different possible numbers that you can use. That's okay. And then, okay. So the number of possible intercepts. Let's just look at the sign on the coefficients. So it goes positive 9, and then negative 45, and then positive 32, and then plus 16. So how many times does it change? So plus and minus is a change, minus and plus is a change, plus and minus. So it's 2, you start with 2, and you start subtracting by 2. 2 minus 2 is 0, minus 2 is -2. The number of x-intercepts can be negative. So it's that. You either have 2 positive x-intercepts or 0 positive x-intercepts. Now you only change the sign on the odd power. So now that positive line is actually negative, 45 is negative, that 32 changes from positive to negative, and the 16 is positive. So now how many times does it change? Just once. So now that means I start with 1, I start subtracting by 2, that's -1, and that's so that tells us that we have definitely 1 negative x-intercept. So if I were to draw my picture, I definitely have a negative x-intercept. But then I either have 2 positive x-intercepts or none. So that would imply that my graph is either going to look like this if I have no positive x-intercepts, or my graph will look like this if I do have 2 positive x-intercepts. So my graph, since it's a cubic, is going to have an odd end behavior. So it's either going to look like that, or it's going to look like that. One of those is correct. Now at this point, I would go ahead and type all this into your graphing calculator and actually see. Because that's going to give you the first number that you can try using synthetic division. And oh my gosh, did you get that right with the 4/3? How did you get that from the calculator?
No.
Oh, okay.
Yeah, that's your brother. Just like, oh,
Right. And so you had that big long list. You could try any of them. But to get to the answer quicker, you just type this into your graphing calculator and look visually at the first x-intercept. And that'll give you the first number to use so that you get the first x-intercept and then move on to the next one. Yeah, so this 4/3 did work. Yeah, worked out. Okay. So now what that means is that your first x-intercept was x minus 4/3. And now you have 9, 33, 12. So you can take a 3 out of all of that. And we're bringing 3 out first column. So that's 3x squared minus 11x minus 4. Okay. Yeah. So now we have to factor this. This we don't have to do more synthetic division, it's quadratic. So you can either just factor it, which I do believe is possible to factor this one, or you can do quadratic. Okay, keep going. Oh, good. Yeah, how's it going?
I'm just having trouble with this.
So the first thing you want to do is factor that denominator so that you can see clearly what's down there. And what multiplies by 3 is 2. Does that work? And that makes sense because I already have a factor that's supposed to be down here. So that makes sense to know. So we want to cancel the denominators. That's our goal, cancel the denominators. And the way you cancel out all those denominators is by multiplying all the way through by the denominators. So if I multiply through by and I multiply that term, that term, then all these denominators will be there. Okay, so if you multiply this times each of those numbers, first of all, it's going to be a lot of stuff to write down. But let's just say we multiply x minus 1 plus 3 times x plus 1. Well, we cancel the bottom. Yeah, that, so really all I have left is x plus 3. That would be my first one. This one, that big one is left, but I think the sign of the bottom half is no longer left. So now let's multiply this whole thing times -9. What would cancel on the bottom? Yeah, so now I can set x minus 1 times -9. That gives me -9 times x plus 1. Okay, so that's that. Now we move on here. What happens if I multiply all this times 8? What would cancel on the bottom? So that is the 8. So that's it. Now I just have this very simple. No fractions at all. So then the 20 is 8.
Oh, so you
And then we distribute.
Nice to know that when I work.
And at this point, it's just a matter of rearranging all the terms. So 9 and 17, we're going to move everything over to the left. If I move the 9x over this side, and then 9 and 17, so we subtract 17 over this side, those will cancel, those will cancel. And I end up with x squared 13 times. So look what we accomplished. We took this big, nasty, terrible fraction, and we got rid of all the denominators. We simplified everything. We got all the terms to the left, and now simplified it. And in fact, this one I think backwards. One times 14. So if we just have 1 and 14.
I'll write it down right here.
So now that equals 0. And then you use this real product and say, well, this times this is 0, so I think this equals 0. That was a lot. But that's the whole process. So at this point, using zero product, we say x minus 1 equals 0, or x minus 1 equals 0. All of these. And that gives us x equals 1, or x equals 1. Now, going back to the previous problem, x, looking at the denominator, x can't equal 1, and it can't equal 1. So it's like the order class, so we know right in front, x can't equal 4. So since x can't be 1, this is 1. And actually, this by 1, this equation is 0, which is fine. So this we call now, of course, right now I do that all again on a separate sheet of paper. Make sure you follow the same reason all the way through. Yes, sir. Let's see. So first, find all the zeros. You are absolutely correct. All the factors. And then you're going to take this in every possible fraction. It'll be 1 over 1, 2 over 1, 4 over 1, drink all that out. There's going to be a really long. Okay, so that's the first question. The next part says, write a number of possible. How many possible x-intercepts do you have? That's what they're actually asking. The number of possible positive x-intercepts. So how many x-intercepts do we have, right? The next question says number of possible negative x-intercepts. How many possible x-intercepts? Okay, so the way this works is you take the sign of those coefficients. So that's a positive. A negative 45. And the method we took is to see how many times is the sign change. So that's plus or minus as the
So that means it changed the total 2 times. And then what you do is you start subtracting by 2. So 2 minus 2 is 0, minus 2 is -2. So you can't have -2 intercepts. So the answer is 2 is x. You either have 2 positive x intercepts, or you have no positive x intercepts. So for the negative x intercepts, you just change the sign on the positive terms. That is x. So the positive line is so how many times does it
It's from the.
So again, we start subtracting. So then you get so these are two possibilities. So you definitely have one negative sign. And then you might have 2 positive x intercepts, no positive x intercepts. And then this is a cubic, our estimated will be this, which means the graph either does this, or the graph will look like this. That's what the graph will look like. No, already, that's incredibly powerful. That's incredibly powerful. No, the graph is either going to look like this or this. That's amazing. And then you already have the list of all the possible numbers where those dots would be. So now it's just a matter of doing synthetic division to figure out which of these numbers is the correct numbers that represent each other. Okay, but I would use your graphing calculator to actually graph it and find at least one of those x intercepts to get the process started. So I wouldn't just randomly start going through the list. I would just graph it and then do that. Did that happen? Yeah. Okay. Yes. Great. Which one? Well, let's see, multiply through to get rid of the denominator. That looks very good. So then x plus 1 equals the negative. Not both of them canceled. Only the x plus 3 in the bottom of the canceled. Well, because in the denominator, you only have x minus 1 to begin with. And in this denominator, you only have x plus 3 to begin with. And in this denominator, you do have both. So here, you only actually cancel the x minus 1. So that leaves you with x plus 1 times x plus 3. Yeah, you're only multiplying the numerator by those things. So the first term would be that. And then that equals -9. So this one actually did cancel, but now you have -9 minus 1. And then on the last part, though, they all cancel out, and you're just left with 8. So now you have that form. So you have to FOIL that out, distribute that out, and move all the terms to the left, and you'll get a quadratic going back. Yeah, very good. Yes, sir. Okay, no other questions? Okay, I'll come back. All right. Oh, yeah, sure, you can do that. That's okay. Or it's just a conversation. It's just a conversation coming down. And in fact, what we're really saying is we're saying we have this on. Which typically means we set this thing. So if you set this whole quickly, 0 here. And
Quadratic.
what I can. Okay.
When it's
If
like
you use it,
this.
you would do that. And in the factor of 4, you can divide the 4 over to the other side. 0
Because when to find the third.
4 just goes.
Somehow,
It's not even a consideration.
I'm like that. So
So if you are in the factor of
so it's okay. Base.
okay. Now, in terms of this, you did the 5 or did the -1 have this? Okay, great. But 5 did this. Okay, so that tells you that this original is actually x minus 5 times this much. And you're going to back to the 4. And so technically, you still have that x minus 5 in front of it. So you can put the 4 up from that. So far, that polynomial is equal to this. So now you have this part. And so you went ahead and you did the quadratic form. So
So 5 with 1 x-intercept, and then the other one is negative plus 1. That's right. Yeah, you got it. So those are the 3 x-intercepts, and I think that's what the problem said. So line all the zeros. That's what you have to provide that. What was your question? You have it all? Yeah, it does not affect this because the 4, technically speaking, 4 is just a transformation. So, for instance, oops, oh, I just erased it. 4x minus 1 plus 1. I'm going to type in the exact same equation, but back to 4. X minus minus 5. Yeah. Okay, so the first one is with this one. Let's change it. So I would know.
Yeah.
Middle left hand. I did with the square.
So it wouldn't be.
There. That's the first one.
See, I connected the minus 4 which would be negative.
Second.
They said you were only counting out the one that was already there, so I just put the one that was already
Oh man. Plus it is of analysis. Yeah, so the writing is by 4, so that divided by 4. Oh, they don't. I'm trying to go.
Yeah.
Here's the first graph, and the second one is going to be a magnification, or actually a division by 4. So if you take that, this one is when you divide it by 4, you would multiply all those values by 4. So the bottom one is a magnification. That's what the 4 does. You'll notice they still have the same intent. What happened is that the graph got magnified. So down to 1 more, see it. You'll see more clearly. That's the original. This one has been switched down by the back. That's what the 4 is. It's just a magnification of the x-intercept. Okay. All right, folks, let's review these next couple of problems. We are on number 7A, and that was done by Valerie. So, first of all, folks, you'll notice that 7A, this top part up here, it's a doozy. You have to write out all the possible factors of 16 divided by all the possible factors of 9. So you have to make all those different possible fractions. And you make out that whole long list, and just one little bit here, you want to have a plus or minus at the very front. So the answer to Descartes' rational roots theorem is this big long list of fractions, and what that represents is all the possible numbers that you could plug in to synthetic division to try to get a 0. And so that's Descartes' rational roots. It's just all the possible numbers that could work. Was that? Yes. I want you to write the whole list. Because what that does, it concretely puts in your mind, oh my gosh, these are all the numbers that could work. Right? There's no other numbers that could work. It's just those. Okay, next, the number of possible positive x-intercepts. I'd like to share with you another way, because I know we did it in class, but let's just look again with just the signs. So if you look at the signs of that function, it's a positive 9, a negative 45, a positive 32, and a positive 16. So the number of possible positive x-intercepts, first of all, you just count how many times the sign changed. So starting with plus,
Plus to minus, that's a change. Minus to plus, that's a change. Plus to plus is not a change. So that means you start with 2, and then you start subtracting by 2. So 2 minus 2 is 0. 0 minus 2 is negative 2. You can't have a negative number of x-intercepts. So that's your possibility, and that's how Valerie got what she got. You either have 2 positive x-intercepts or no positive x-intercepts. What would that look like? If you have 2 positive x-intercepts, that means you'd have 2 points over here to the right that represent x-intercepts. Or you have no positive x-intercepts and you have no x-intercepts to the right. So that's the first result. The number of possible positive x-intercepts is either 2 or 0. You either have 2 positive x-intercepts or none. So now, how about the number of possible negative x-intercepts? You take the original polynomial and you change the sign on the odd-powered terms. So since we started with 9x cubed minus 45x squared plus 32x plus 16, I'm just going to change the sign on the coefficient on the odd-powered terms. So x to the third is odd, x to the 1 is odd. So now I'm going to change these signs. Instead of positive 9, I'll make it negative. I'll keep the negative 45. Instead of positive 32, I'll make it negative, and I'll keep the positive 16. So now I'm saying, how many times does the sign change? Negative to negative doesn't change. Negative to negative doesn't change. Negative to positive does change. So that's a 1. And again, whatever number you put down first, you start subtracting by 2's. So 1 minus 2 is negative 1, but I already stopped because I can't have a negative number of x-intercepts. So what that tells us is I definitely have 1 negative x-intercept. So over here to the left, I definitely have 1 negative x-intercept. So look at my 2 possible graphs. I definitely have 1 negative x-intercept, and I either have 2 positive x-intercepts or no positive x-intercepts. Look how powerful this result is. It tells me that my graph either looks like this or it looks like this. That's incredibly powerful, that I already know what my graph will look like. It either has 1 negative x-intercept and 2 positive x-intercepts, or it has 1 negative x-intercept and no positive x-intercepts. Again, that's just a really powerful positive result, telling you what your graph is going to look like. So now, that said, when you actually do the synthetic division, what you would, if you were on a desert island, what you would do is just start working your way through those numbers until you find one that gives you a 0. But you're not on a desert island. You all have calculators. And what I recommend you do is, if you're doing homework at home, you could just go to Desmos, type in that polynomial, and find the first x-intercept. And that way you don't have to sit there and just guess and check and guess and check and guess and check. But on the test, what you can do is type the polynomial into your graphing calculator and use your graphing calculator to find the first x-intercept. And that way you know what number to use in synthetic division, and you're not just guessing and you're not guess and check. So if you did actually graph this on your graphing calculator, would you see that the first number is 4? Does everyone agree with that? Does 4 work? It does? Okay. So who was doing this still? Valerie? So Valerie plugged in the 4, so she dropped the 9, 36, negative 9, negative 36, negative 4, negative 16, 0. Okay, perfect. And then she started in a cubic, so now she has 9x squared minus 9x minus 4. So that gives us so far, did you come over here? Is that what you did? Yeah, you finished factoring over there? So one of her terms is x minus 4. And then the rest of her term is 9x squared minus 9x minus 4. That's what Valerie has so far. By just doing synthetic division once, she got one of her x-intercepts, and now she has this. So now what did you do, Val? Did you try to factor? Yeah. So Valerie tried to factor. She did 9 times 4 is negative 36. She found the numbers that multiply to make 36 to add to make negative 9, and those were 3 and 12. She split that up, pulled out a 3x, right? Yeah, pulled out a 3x. Over here, pulled out a negative 4. It didn't work, did it? That would be 3x plus 1. And now those are the same, and she would have it factored as 3x plus 1 and 3x minus 4. So now that becomes her final factored form, x minus 4 times 3x plus 1 times 3x minus 4. Okay, so this is the factored polynomial. We're done. We've factored it. Now we still need to write down all of our x-intercepts.
So you'd set each of those equal to 0, and your x-intercepts would be 4, -1/3, and 4/3. You'll notice that -1/3 is on the list up there, and 4/3 is on the list up there, and so is 4. So all of these numbers that actually did end up being the x-intercepts are on the original list from Descartes' rational roots there. Did that cover everything? We should erase stuff. Oh, that's the previous problem. That doesn't matter. Oh, that's where you had it, Val. Is this still you, Valerie, or is this the next person? That's, okay, so now that's Andrew. Yeah, there we go. So then Andrew took over. Andrew had the the y-intercept. He plugged in 0 and got the y-intercept of 16, is that right? Yep. So 16 is his y-intercept right up there. The end behavior he knew was a cubic, so it was going up and to the right and down to the left. And then he listed out the x-intercepts for us, which was 4, -1/3, and 4/3. Then he graphed them, and that's what it looks like. Folks, number 7 is quite the problem. Right? It'll take up more than half a page on your test to go through and list all those things out. I'd say the main thing is, even though you have to write out Descartes' rational roots theorem and write out all those numbers, you don't have to use trial and error to actually find the numbers. You can just use your calculator, graph it, and then see what the x-intercepts are, and then use those x-intercepts to do the synthetic division to allow you to keep factoring. What questions would you like to ask about this one? That's quite a long problem. I would definitely practice that over and over until you can do that problem all the way through without batting an eye. All right, well, thank you, Val and Andrew. How number 8? This was Valentine. Valentine, right? Yeah. So you go by Val. Valentine Hume. Is it Hume or Huma? Huma, there we go. All right, Val. So factor the polynomial, draw a graph. So this problem is number 7, but you don't have to show all that work. Number 8 is essentially just like number 7, but it basically just says, hey, go ahead and do it. So factor it, draw a graph with the x-intercepts, the y-intercepts, and the end behavior. This problem is very scaffolded. I want you to show me your work and your thinking all the way through. This problem just says, go ahead and do it. So Val started off by doing all of the Descartes' rational roots theorem. He knew that it was either 1 or 7, plus or minus. And he went ahead and tried 1, and it worked. And that allowed him to get one of his factors. I don't think you wrote this down, but one of your factors would therefore be x minus 1. And then the other thing would be x squared plus 6x plus 7, right? So far, that's what Val accomplished by doing synthetic division with a 1. He broke his polynomial into here. And then is this factorable? What multiplies to make 7 that adds to make 6? It could be 1 and 7 if it were a positive 7 and a negative 1. Then it would be that. But this has to be a positive 7, which means what multiplies to make a positive 7? Either 1 times 7 both positive, or 1 times 7 both negative. And if you add those together, you either get positive 8 or negative 8. You don't get 6. So this one is not factorable. It's not factorable, and that's why Val proceeded to do the quadratic formula. So he did negative b plus or minus square root b squared minus 4ac over 2a. And he ended up getting negative 3 plus or minus root 2. Is that right? Yeah. So notice that's 2 different numbers. One of his x-intercepts are negative 3 plus root 2, and the other x-intercept is negative 3 minus root 2. So you can see when he's all done here, he had his x-intercepts were 1, negative 3 plus root 2, negative 3 minus root 2. He knew his end behavior was a cubic, so that's what his end behavior looks like. Those are his x-intercepts. His y-intercept he knew from the very beginning was negative 7. And then he built a graph. And so his graph here captures everything that he knew. Now, Val, how did you turn negative 3 plus 2 or root 2 into your decimals? Yeah, you just use your calculator, right? You just type negative 3 plus root 2 into your calculator, you get a decimal. That's where he got the negative 4.4 and the negative 1.6. There's the 1. There's his y-intercept of negative 7, and his end behavior matches. So really nice, Val. That's perfect. I would definitely give full credit for this problem. You didn't even have to show me the Descartes' rational roots theorem. It's nice that you did, but you wouldn't have necessarily had to show me that. What I really just wanted to see was your synthetic division, the quadratic behavior, the quadratic formula, and then your graph. Ultimately, I'm looking for the x-intercepts, the y-intercept, the end behavior, and drawing a graph. So that's a wonderful graph. It looks great. Now,
What if one of you had the clever idea and you said, Mr. G, I just graphed it and I found out that it went through negative 4.4 and it went through negative 1.6 and it went through 1 and it went through negative 7. I saw all that on the graph and I just looked at it and I just drew it. Would I give full credit to somebody who just typed that into their graphing calculator, found all those values on the graphing calculator, and graphed it? So what if this was all you gave me? And that was it. So you took the test, this was number 8, and you just showed me that graph. Would I give you full credit? No. I mean, it does say factor the polynomial. So there's one thing, factor the polynomial. If you just drew the graph, you hadn't factored the polynomial yet. So this was the first part of the factoring of the polynomial. We're not technically done yet. And then drawing the graph, and you did do it. So really, we need to finish factoring this polynomial. And to do that, remember, it's always f of x equals x minus, x minus, x minus, and then you just drop in all of your x-intercepts. So that'd be x minus 1, x minus negative 3 plus root 2, and then x minus negative 3 minus root 2. And that would be the factored form of the polynomial. Did I put that on my solution key? Does anyone have the solution key in front of them? Oh. Oh, I just listed out the x-intercepts, did I? Oh, okay, well, on my solution key, I did not actually write out the factored form. All I did was write out the x-intercepts. So, gosh, what do I really want from this problem? I wonder if that's going to turn back on. I don't know. Well, my point is, folks, don't just do the graph. I want to see your work. Remember, I've said it over and over in this class, we're learning the skills that you could draw the graph without the graphing calculator, even though you are allowed to use the graphing calculator. So if you did this whole problem with just your graphing calculator, I wouldn't give you full credit. I want to see your synthetic division work, and I want to see how you got to the answers. All right. Okay, well, that makes us done with number 8. So I wonder if, did it just go to sleep? Is that what happened? Oh my gosh, it went to sleep. Folks, I don't know how I should feel about that, that I even put a computer to sleep. Oh, man, that's rough. All right, there we go. Number 9. So this is 9A, 9B, 9C, and number 10. So let's have Perla, Reina, me, and Isis. Let's all come up and do these problems. I'm going to erase all this. I'm still walking around the room going person to person, so when I get to you, I hope you have a question for me. Otherwise, you can continue using this time to talk with your neighbor and work on your practice test. I've seen a couple of you using your smartphones to pull up Canvas, to pull up the solution key, so that you can be looking at the solutions as you fill it out. I think that's a very fine idea. And remember, your practice test is due on Wednesday, so if nothing else, you can just use this time to finish that. Finish your practice test. All right. So, Perla, Reina, and me. I think. Yeah. I'm going to say Perla, and then I'll say Reina, and then I'll say, there we go. And then who's number 10? Isis. All right, come on up there, folks.
Point for alert, I realize that's kind of tall. I don't want you standing on a chair. You could always just write your answers over here if you want. All right.
What's that?
You can just write it down.
Yeah, you can put it anywhere.
Okay, let's see. Yes, you do. What questions have you got? What about Right, so here's all the possibilities. If you have a positive x to the 6, then that will look like this. If you have a negative x to the 6, so even is always or if it's odd, x cubed, then you have a graph that goes up to the right and left. Or if it's flipped upside down, then it's going to go down. So these are 4 fundamental possibilities. What is what? Why is it? Well, right. Oh, I see what you're saying. Because it's cubic.
Tell me what chips and the diet.
The tails go in the same direction. Both up and both down.
I don't know, I got like,
One.
I need to add those.
So this you have 4 up down, and here you also have 1. It's just the positive. It's up to the right. It's negative. It's down. But then it's too fun. Okay, yeah. The other thing that you do, like let's say you're sitting in the middle of a test and you forget, just graph it. So like here's, they go into graph, and then you first execute. That shows you what an execute graph looks like. And definitely execute looks like this. And then if I go into y equals, and I put in negative signs, it's negative execute. That looks like this. So you know this graph, it's just a basic even power, so what they look like, a basic odd power. Yeah, another question. This one right here. First two people, what's your question? Right, that's your goal. Get rid of them.
Yeah.
Well, you're going to multiply all the way through and get -1 and x plus 3. You're going to multiply that by this denominator, that numerator, and now we're going to cancel this x minus 1 and this x plus 3 multiplies. So like for instance, the first one, I multiply this numerator, the x minus 1.
Well, I know that it had
That's the first.
that one and the
And I have equal sign. Now I'm going to multiply both of these. Now I'm going to go ahead and multiply both of these times this fraction. It's going to cancel both of those. So that's the first step where all I've done is just cancel all of them. Now I can FOIL this. And I can distribute this. And that's going to give me a whole bunch of terms that I need to move all to the left. So I'm going to quadratic, which is Did that answer your question? Thank you. Thanks.
Yes, sir. You know, I never understood what to do when there was a parent. I always like it. I don't know, I was just confused.
Okay. So
Sometimes they would multiply that and that.
okay. So first thing back.
And then other times they would like, oh no, you just take it out.
Makes sense because this is always. So what we want to do is cancel. Yeah. This is multiply the whole thing all the way to us.
Well, given that the power is literally the end behavior, is that Joker face? The Y says.
So now I have a basic instruction. Now it asks me like, oh, I want this. Distribute this.
That's what I say.
The intercept is just.
Maybe it didn't be.
Maybe still on the board.
All right, folks, let's keep going. Perla did our first couple of problems for us. First, she expressed the root of negative 144 as an imaginary number, which she did by breaking out the negative 1, and so it just became 12i. And that's perfect. 12i is totally acceptable. I realize that some people might say plus or minus 12i because you technically did a square root, but I would give you credit either way, whether it's plus or minus 12i or just 12i. It's either way, I would give you credit. 12i is probably the answer I left in the answer key. Okay, and then Perla also did adding those two numbers and subtracting them. You'll notice it's the same expression. Either way, this first one is really, let's see here, 24 minus 6i, and then it's plus negative 22 plus 12i. So both of those are going to be 24 minus 6i, and then either plus negative 22 plus 12i, or the next one is just a minus between them. So you're using the same numbers twice. And that's what Perla has here. She wrote it down, and then she converted those square roots of a negative number into I terms, so 24 minus 6i plus negative 22 plus 12i, same thing I got. And then she combined like terms, and she got 2 plus 6i. In the very next problem, she just subtracted those two terms instead of adding them, and she got 46 minus 89. Right? Yeah. Wait, that was a negative 22, right? Maybe I just can't see your negative sign. Anyway, so that's it. Really nicely done. We're just combining numbers with imaginary components. So thank you, Perla. Raina went ahead and did. Oh, over here, thank you. So Raina went ahead and did the product of root negative 6 times root negative 24. So she pulled out both of the I terms out front and called that I squared, leaving behind the root 6 times the root 24. Root 6 times root 24 is root 144, which is simply 12. And she had all that multiplied by I squared. I squared is really negative 1, so the answer is just negative 12. What's really interesting about this is if you have a TI-82, first of all, TI-82s can't do this calculation at all. I would just say error. But if you have a TI-83 or higher, you can actually type this into your TI-83, and it will actually tell you the answer, negative 12. So I don't know if any of you have a TI-83 or a TI-84 or a TI-85 or anything higher than an 83. You can actually check your answer here by plugging it into your calculator. If you merely have a TI-82, you cannot do that. Okay, thank you, Raina. The next one, 3i squared. That is 3i quantity squared. So that's 3i times 3i. Raina, I really like how you wrote that out. It's 3i times 3i. That gave her 9i squared, which was 9 times negative 1, which is negative 9. So that's perfect. Really nice work here. I'd give full credit for that. Thank you, Raina. JW, where's JW? Right here. He did I to the 26th. So remember your method for simplifying I to some large power is to take that power, divide it by 4, and replace it with the remainder. So I to the 26th is actually equal to I squared. And I squared you all have memorized is equal to negative 1. You might want to make a note that I to the 1 is I to the 2 is negative 1, I cubed is negative I, and I to the 4th is 1. And those are the only 4 that you really have to memorize, because you're always going to take this exponent and divide it by 4. The remainder is always going to be 0, 1, 2, 3, or 4. All right. And then finally, also find the product of 5 minus 3i and its conjugate. Remember the conjugate, you just change the sign in between the two numbers. So the conjugate of 5 minus 3i is 5 plus 3i,
I multiply them together using FOIL. The middle two terms cancel out. I have 25 minus 9i squared. I squared is really -1, so that's really minus 9 times -1, which is really plus 9, so 25 plus 9 is 34. All right. Next, number 10, ISIS. Find all the zeros of this problem. This is a great problem because it's just very open-ended. There's no real instructions other than just do it. Find all the answers. So you'll notice that ISIS started by plugging in a 5. How did she know to do 5? Did you just randomly guess? What did you do? You plugged it into the calculator and she saw that across the x-axis at 5, and that's how she knew to start with the number 5. And I encourage all of you to do the same thing. If you're going to do synthetic division on a polynomial, type that polynomial into your calculator so you can find at least one x-intercept and use that for your synthetic division. So what did she get then? The 5 becomes x minus 5. She had 4x squared minus 4x plus 4. She went ahead and pulled out a 4 out in front, so she had 4 times x minus 5, and then what is left is x squared minus 1x plus 1. So far this is what she has. Right? So far she was able to factor out a 4 and an x minus 5. She still needs to factor x squared minus 1x plus 1. So this is not factorable. She has to use the quadratic formula. So she did the quadratic formula, -b plus or minus square root b squared minus 4c over 2a. And she ended up with this expression, 1 plus or minus root 3i over 2. And so she broke that into two separate fractions, either 1 over 2 plus root 3 over 2i or 1 over 2 minus root 3 over 2i. And then she just listed out her x-intercepts, and there they are. Notice, had you used Descartes' rule of signs and said, what are all the positive x-intercepts? Then the sign changes would be positive to negative, negative to positive, positive to negative. That's 3. So that would either be 3 or 1, or that's it. Whereas for negative, how many negative x-intercepts are there? Then this would be a -4, a -24, a -24, a -20. You'll notice there are no sign changes. So the total number of negative x-intercepts are none. There are no negative x-intercepts. And you'll notice we don't have any negative x-intercepts. We only have a positive x-intercept. So that worked out that you have no negative x-intercepts, but you either have 3 or 1 positive x-intercepts. Now, obviously, we do have 3 solutions, but we only actually have 1 x-intercept because imaginary numbers aren't actually x-intercepts. If you looked at this graph, the graph would go through 1, 2, 3, 4, 5, but that's it. It would look something like that. So 2 of the solutions are imaginary, meaning they're not actually x-intercepts, but they are nevertheless numbers that if I plugged into this equation, it would give me a true statement. Okay, so we have 5 minutes left. So far, this is great, folks. Obviously, we're not going to be able to finish all of the rest. But can I just tell you, the 10 of you or so of people who came up, this was wonderful. This is exactly what I wanted to see. So I think what I'll do, since some of you didn't get to come up to the board, and I know that you're very upset by that. You're like, hey, what the heck? I wanted to come up to the board too. I'm just going to keep track of everybody who didn't get to go up yet. And that way, the next time we do this, I'll start with you folks. And that way, everybody gets to have a chance at this. Okay, that's fair, right? You're all laughing because you're happy. Okay. So now, let's talk then. We only have 5 minutes. We didn't get to finish reviewing all of these problems, but I do want to help you. So how do we do this? You have until Wednesday to finish your practice test. These solutions are online, so obviously you should download the solutions and look at them, especially my solutions, because my solutions are what I would give full credit for on the test. So if you study my solutions, you're fine. But does anyone have any questions you'd like to ask now, since we only have 5 minutes left? Any last minute questions? Okay, well, nobody wants to ask a question right now. That's fine. You can all come to my office hours. I'll be there right after class or later today from 1 to 2. But as far as the rest of the problems go, as I said, you can just look up the solutions online. What about the online homework? Does anyone have any questions about the online homework? Maybe yes, maybe no. Folks, you'll notice there are quite a few problems in the forum. So in chapter 3, there's 6 problems in the forum, and in chapter 4, there's 3 problems in the forum. So when you're studying for your test or doing your homework, make sure you're looking in those forums because you'll see other solutions. Okay, well, folks, I'm just using this time to answer anyone else's questions. So if you have questions, come ask me. Yeah, Andrew. There's not 24.
Andrew.
You're laughing. I did.
Okay.
You just said what? You're like,
Must be.
So that means I.
that way
You like that? Give me my supplement.
The signs here, so the fourth, we have to be going to the side. So now it's the same time to use the sign. Positive doesn't change. Positive doesn't change. So there's two changes of sign. So now I'm doing the first test here. So there were two changes of sign. And then you say P for positive intercepts. There were two changes of sign. And then from that number, I start subtracting 2. So 2 minus 2 is 0, and then 0 minus 2 is -2. But this list is supposed to represent the total number of positive x-intercepts I have. Meaning, I'm over here on the positive x-axis. How many x-intercepts do I have? Well, I can't have a negative number of x-intercepts. That doesn't make sense. So I either have 2 positive x-intercepts or no positive x-intercepts. So over onto the right of the graph, I either have 2 x-intercepts or I have none. That's what the rule says. So going back, suppose f of x is polynomial, and if P denotes the number of variations of sign, that's the variation of sign that changes in sign.
So.
In that formula,
It's
then the
okay.
number of
I
positive
think
real
so.
zeros, x-intercepts, is one of the terms P plus 0 equals 4. So again, this just means you take the first number times 2, and you subtract by 2. So minus 2 again, minus 2 again. That's why it says P minus 2, P minus 4, because you're always subtracting 2. Yeah, just 2 over and over and over. Yep, if somehow you started off and the first number was 6, then you write down 6, and then subtract 2, and then subtract 2, and then subtract 2, and you stop at 0. So that polynomial would either have 6, 4, 2, or no positive x-intercepts. Okay, so then what do you do? N denotes the number of variations of this formula, and when you plug negative x into the function, what it does is change the sign on the odd terms. So it's going to change that sign, and it's going to change that sign. So now it would be plus, well, it's going to be plus, and then minus, and then minus, and then plus, and then plus. So now how many times does the sign change? Plus or minus is 1, minus minus doesn't change, minus plus does change, minus plus doesn't change, that's 2 again. So the total number of negative x-intercepts is either 2, and then you start subtracting by 2, so either 0, and then negative 2, you can't have negative x-intercepts. So the total number of negative x-intercepts is 2 or 0. Okay, well that's how that rule works. Try that out once, right here, while I talk to Fran and Carlos. Did you guys two know each other before this class?
Yeah.
Oh, okay, that's fine. Did you have other classes together?
Mm-hmm.
Very cool. Okay, question is. Okay, so what you have right here is 82 over 192 times x. You can think of it in a couple different ways, whatever's most comfortable to you. You can do traditional algebra, and that says that x is being multiplied by 28 and divided by 192. So you can always start by multiplying by 192 on both sides. If that's what you want to do, you can do that. That's totally fine. So that way, that is gone. And so now you have 28x equals 1 over, I'm sorry, 1 times 192, which is just 192. And now you're going to divide by 28. So we take both sides, we divide by 28. Over here, I divide by 28. So now those 28s cancel, and I'm left with 1 times 192. And you'll notice that what I just did is equivalent to multiplying, since x is being multiplied by the fraction 28 over 192, Another way of solving this problem is multiplying both sides by the reciprocal. I took the reciprocal of 28 over 192. I multiplied this side times 192 over 28. Multiplied this side times 192 over 28. And that way, those 192's canceled and the 28's canceled. In any case, what's 192 divided by 28? And over the steal your calculator. But I'll give it right back to you. So it's 6.857. Okay, so that's our solution. So we could probably just round that. It says how long do they work together? Yeah, so 6.91 hours. Yeah. So going back to your question though about the algebra, when you get all the way down to 28x over 192, you can go ahead and just do algebra. So multiply up by 192 and then divide up by 28. That's fine. Or you can say to yourself, this is really x times the fraction, 28 1/92. Right? Is that the same thing?
Mhm.
Yeah, so in that case, if I just multiply both sides by the reciprocal, so that's 192 28, that automatically cancels out that over there, and I'm just left with 192. Doing it the algebraic way is just fine, but this is technically faster to multiply by the reciprocal, and it sounds good and sophisticated. Like, what would you do? Multiply by the reciprocal.
Okay.
Carlos, did that answer your question over here?
No, it's a different question.
Oh, okay, go ahead. So, Brandon, does that answer your question?
Yeah.
Okay.
I just use this space to write it in. So my question was about number 8. So it simplifies down.
Chapter 4?
Chapter 1.
Okay, number 8. I'm going to go back and look at it. Okay.
So it's with the Sunda right here. With this part.
Now, real quick, when you do synthetic division, you don't have to put all those x cubes in there. That makes it. I feel like that makes it a little harder. Just so you know, you don't have to, because like that's a 1 right there. Okay. You can put those x's in there. Just so you know, you're the only person in the history of my life I've ever seen do that.
Really?
Yep.
I
And
just
that's
think it's
fine.
one.
Hey, and if you like to do it this way, that's fine. You can do it that way. But other people are going to look at this and say, "Whoa, what are you doing?"
X?
Yeah, I'm not judging. It's totally fine. If you feel comfortable doing that, you can. Just so you know, you're the only one. Okay. So now you plugged in the 1. It did work. Yeah, you got it a 0. So then you have this.
My question is about here when it gets to this part.
Yes.
And so once it gets to this part, I'm a little bit confused on how you simplify these.
Okay.
This is really my question.
Sure.
So
How
I
to
can see
simplify.
how like this is like 2 cubed. So you take like one of the 2's out from the cube.
You can think of it that way.
But what about like this? Can you do anything?
Is that
with this one?
26?
Yeah.
Nothing can happen with 26.
So
Because if you factor 26 using a factor tree, it's just 2 times 13. And you don't have anything squared in there.
so let's say it was like -6 plus or minus square root of 26.
You just be done.
Oh, okay, awesome.
Oh, that was your whole question?
Yeah, that was my
Because
whole
you had
question.
some good choices here. Like 34 is also just 2 times 17. It cannot be simplified.
Yeah, and that's why I put these examples because I see that these ones can
yeah.
be like.
Yeah, those can be.
Yeah,
Yeah, cubes
take
will
out
always
a
work.
cube, but
Well, let's just take something that's not a cube, just so you see it. Like, let's say you wanted to do the square root of, how about 28?
Mhm.
So 28, if you were to do a factor tree, and, well, there's a lot of different ways you can do this. With 28, if you did a factor tree, you'd see that that's equal to 2 squared times 7 to the first.
Oh,
And then you could
now I
have
remember
2
that from like high
squared and
school.
then 7 to the first. So then this one actually simplifies to just 2, but that you're just left with root 7. So that's another way you could do it. But see, I would just look at 28 and I would think, what are all my square numbers? What square number goes into 28? Just 4. So I would take root 28 and I would break that up into root 4 times 7. And I chose 4 to be a square number that goes into 28. So that way I have root 4 and root 7, and then I just have 2 root 7.
That makes
There's a lot of different
like,
ways that you can get to 2 root 7. Another way I see people do, which is very fun and clever, is they take 28 and they rewrite it as 2 times 2 times 7. And then anything you have a pair of, you can take out. So then you just say
that's
2 root 7.
Okay.
It's neat, but it's magic. It doesn't really explain why that's happening, but it's a really nice visual technique that works every time. Which is why, like in this case, root 34, that's really 2 times 17. I don't have a pair of anything, so I can't take anything.
Yeah. All right. Awesome.
This technique also lends itself to cube roots. Let's say that you had a cube root of 24. Well, so 24 is really
then the cube root. That's 8 times 3, and 8 is really 2 times 2 times 2 times 3. So when you do a cube root, you're looking for triplets, and so I can take out this triplet of 2's, and then my answer is 2 cubes of 3.
Okay, awesome. Yeah, that makes a lot of sense.
Very good.
Appreciate it.
You're very welcome. Andrew? Oh, good, you tried it. So that would be negative, positive, positive, negative. So the number of sign changes is just 2. And then here you change this, that one to positive, positive. This one has to change into a negative. Because you change just the odd powered terms. And you're right that x to the 3 is odd, x to the 1 is also negative. So that would be negative. So then the number of sign changes is no, yes, no. So it's still 1. So it doesn't change your overall answer. Okay, very good. Go for it. Okay, let's go up to my office just to make sure that if somebody else is coming up there, I'll be able to be there. Brandon, Carlos, did I answer your questions?
Yeah.
You're happy campers? Thank you both for the number of times you emailed me and posting questions to the forum. I think that's really helpful.
Yeah, no problem. Awesome.
I also appreciate that you don't make me pay you to do it. You just do it of your own free will. That's very kind of you. See ya. Oh boy, I have a lot of erasing to do. Well, maybe not that much erasing to do, but fair enough.
Yeah, I had a question on the board.
Yeah.
I don't know what I'm doing wrong because I'm pretty sure I'm following everything that they're doing on the video.
Okay.
It's just